we come to the final topic of flip-flops, and this is dealing with flip-flop conversions. That means we have studied all these different flip-flops SR, D, JK, A, JK, T. So all these flip-flops can be converted between each other. That means if you have a SR flip-flop, you can convert it to a D flip-flop. If you have a D flip-flop, you can convert it to a SR flip-flop or a JK flip-flop or a T flip-flop, like that. That means, like, unlike your gates, where there were universal gates, here we don't have such a concept of universal flip-flop, because all the flip-flops can be converted to each other, and that is the thing. And I hope you also have come to understand that when we are dealing with this part of the course, which is a sequential circuit design, and we are talking about memory elements, so now we have basically come from the level of logic gates to an upward level, which is the level of flip-flops. So the basic transistors were used to make the logic gates. So we dealt with the entire combination circuit design, treating logic gates as the basic elements of our circuit. Now when we are coming to sequential circuit design, we have made some basic circuit, elementary circuit using the logic gates, and these circuits we call the flip-flops. And now the flip-flops become the basic elements of the sequential circuit design. Along with gates will also be there, but flip-flops are the basic memory elements, which we will be using in the sequential circuit designs. So that is what is flip-flop. So now we will understand how to convert between different flip-flops. So there, first thing one needs to understand is identify the available and the desired flip-flop. So in the problem, you will be given like this, that convert SR flip-flop to JK flip-flop. What does it mean? That SR flip-flop is available. That is why you are able to convert it to something which is not available. So you are going to convert it to JK flip-flop. So JK flip-flop is not available, but it is the desired flip-flop. So you have to identify what is the available flip-flop and what is the desired flip-flop. So when you have identified it, you have to make the characteristic table of the desired flip-flop and excitation table of the available flip-flop. Then write down Boolean expressions for the available flip-flop in terms of the desired flip-flop inputs and present state. You will get a Boolean expression. Then you have to draw up the circuit. So just by looking at the statements, you would not understand much of it. So let us go into a example. So here we are trying to make JK to D flip-flop. What is available? JK is available. What is desired? D is desired. So go into the steps. Make CT of desired flip-flop. So characteristic table of desired flip-flop, which is the D flip-flop. So you see the characteristic table of D flip-flop in this orange table. Then excitation table of the available flip-flop. So excitation table is in the green table, available flip-flop, JK flip-flop. We have written down the excitation table of the JK flip-flop. So for the flip-flop conversions, basically the characteristic table and excitation table becomes very important. And both of these you don't need to remember. You have to only remember the truth table. From the truth table you can always derive the characteristic table and the excitation table. If you are able to remember, that is well and good. It is in your own advantage. But even if you cannot remember, you can always derive it from the truth table. So if you have the truth table, you will always be able to find out the characteristic table and excitation table. It might take a few more minutes, but you don't need to memorize these things. So that is what I am trying to stress here. Now what is the next step? Write Boolean expression for available flip-flop in terms of desired flip-flop inputs and present state. So what we do basically, we would take up this part from the excitation table of the JK flip-flop. So this is the excitation I need to give. This I will take up and append in the characteristic table of the D flip-flop or the desired flip-flop. So now I can try to understand how I will form these JK inputs when my desired Qn and D are like this to give me Qn plus like this. This is what I will try to do. So when my Qn and D is like this, so you see that this Qn plus, this has formed my JK, right? So Qn plus being 0 0, what my JK would be, that is what I have tried to write down, 0, and this is don't care. When my Qn is 0 and Qn is 0 and Qn plus is 1, this is the combination, Qn is 0, Qn plus is 1, I should give JK as 1, don't care. Qn is 1, Qn plus is 0, JK is don't care and 1, Qn 1, Qn plus is 0, I have put down what my JK should be. In this way I have formed the table. Now this is the table now. Here that Qn plus column is omitted because what you are having with you is basically Qn and D, and with that you will be generating the JK inputs so that your Qn plus becomes as desired. That Qn plus which we omitted, so if you can design JK with the help of Qn and D, then the Qn plus will become like this as desired. That is what we are trying to do. We are trying to form J and K only, and that would give you rise to that Qn plus. So J and K we have to figure out using the K map. So that is what we have done here, and you can understand that J would be D. So here this is the basically EPI, and here this is the EPI. So here you see that J would be your D only, and K would be your D bar. Okay, K would be D bar. And now you have to make the circuit. So in the circuit you have a JK flip-flop and you have a D input. So you are using the JK flip-flop. That means what you are actually trying to form is the input of the JK flip-flop using the D flip-flop, using the D input. Here the Qn, the output does not come here in the picture because J is directly D and K is directly D bar. Okay, and you are drawing the circuit like this. Let us see another example. Here we are trying to form SR2JK flip-flop. Desired is JK flip-flop, given is SR flip-flop. We already have looked at this circuit when we have studied JK flip-flop. So let us see if we go step by step, we are able to come to the same circuit or not. So we have the characteristic table of the JK flip-flop and the excitation table of the SR flip-flop. What we have to do? We have to write down S and R in terms of S and R when my Qn and Qn plus are like this, whatever is here in this rows. So Qn plus is 0 0 for both these rows, it is 0 0. So when Qn plus is 0 0, S and R are 0 and don't care. So you will have 0 and don't care, 0 and don't care. When Qn plus is 0 1, Qn plus 0 1, S and R is 1 0, 1 0, again 1 0. When it is 1 0 1 0 1, right? When it is 1 1, so when it is 1 and 1, then it is x and 0. So when it is 1 1, this is x and 0. Another instance is here, Qn and Qn plus x and 0. when it is 1 to 0, so when Qn is 1 and Qn plus is 0, Qn is 1, Qn plus is 0, your S and R are 0 and 1, 0 and 1. Okay. So now what you have to do, you have to form the K-map. You have to form the K-map. Let us try to form the K-map of S, and we don't use this column, so this column will not be used. So this is S, we have Qn here, Jk here. So Qn, when this is a combination 0 0 0, it is for S it is 0, so we are trying to put ones and x's. So let us see when it is 1 0 1 0, 0 1 0 is 1. So let me use another color here. Sorry. So let me use black. So 1 0 1 0, then 0 1 1, 0 1 1 is also 1, 1 0 0 is x, 1 0 0 is x, and 1 1 0 is x, 1 1 0 is x. So this is the thing, but you see that this x is not very useful here, because already we can form an EPI with these two ones together. So your S will be basically Qn bar, and which is not changing, J is not changing, J Qn bar. And then what is your R? So for R we again form a K-map. JK 0 1 0 0 0, and now R you see 0 0 0 is x, 0 0 1 is x, 1 0 1 is x, 1 0 1 is x, not x, 1, and 1 1 1 is 1. Here also you see this x does not really contribute much, because we can readily form R from here, which is your Qn k. So k Qn, and this I hope you remember, S equals to J Qn bar, R equals to K Qn. I think we already saw this equation before, but what does this mean? That you have to form these SR inputs. So the SR flip-flop is here, S and R, Qn bar, and S is formed by J Qn bar. So there is a J input and a Qn bar ANDed together, and it goes to S. And what about R? R is K Qn. So there is a K, and Qn will come here and go like this. Don't forget to give the clock, otherwise it does not become a flip-flop, clock being age triggered. Okay, So that is all. So we have successfully done the conversion. This is already known to us, this particular SR to JK, but you can also do JK to SR flip flop. You can do any X to Y flip flop. So all that possibility is there. So you can practice on your own, and that is all. Thank you for your attention.